Hello everyone. Today we are going to take a look at the machine used in die and mold manufacturing. It's very nice to meet you. I am Robert Choi, a professional engineer die and mold. My Korean name is Hungbong Choi, but you can simply call me Robert Choi. Not long ago, I received a call from someone I have known for several years. He wanted to ask me about the cost and production schedule for mold. He is still working for a company that manufactures foam products for automotive interiors. While we are discussing the mold manufacturing schedule, I realized that even though he was working in his field, he did not seem to understand how molds are actually machined. Everyone, if you are currently involved in product development or mold development, shouldn't you have at least a basic understanding of how molds are machined? Even when you request a quotation from a mold manufacturer, you need to understand the machining processes, the machines used, and the time required for each process. Only then can you determine whether the quoted prices is reasonable. Alright, that is enough for the introduction. Now let us move on to the main topic. Those of you working in the manufacturing industry have probably heard of the machine called an MCT or a machining center. It looks like the machine shown in this picture. Machining centers are generally quite large. It may be difficult to understand how they work just by looking at the outside. So let us take a look at inside. You can see a table at the bottom, a tool holder and spindle above it, and a control panel that looks like a computer screen on the right. This is a machining center, commonly called an MCT. The basic structure of machining center is similar to that of a conventional milling machine. It consists of bed, a column, and components corresponding to the X, Y, and Z axis, such as the knee, saddle, and table. These components are equipped with servo motors and servo control systems. The table moves forward, backward, left and right, while the cutting tools and spindle move up and down according to NC commands. A machining center is also equipped with an automatic tool changer or ATC. This allows the machine to automatically change cutting tools and perform various operations including milling, drilling, boring, and complex contour machining. This green section is the workpiece, and the end mill rotates and moves in the direction of the arrow. It cuts the workpiece and creates a rectangular groove. Everyone, I would like to introduce a YouTube that explains MCT machining in a very simple and easy to understand way. If you visit this channel and watch the video, you will be able to understand the basic principles of machining center operations much more easily. Next, let us look at the CNC lathe. A CNC lathe is an ideal machine for machining cylindrical or rotationally symmetrical workpieces. You are probably familiar with the conventional lathe used to machine shafts. Simply put, a CNC lathe is similar to a conventional lathe, but it is equipped with servo control systems like those used in the machining center. A CNC lathe generally looks like this. Its external appearance is quite simple. Now let us take a look inside. The part level rotation is the headstock. The headstock transmits the rotation of the spindle motor to the chuck, mounted at the front of the spindle through belts and transmission gears. The picture at the bottom right shows the tool tread. Depending on its design, a tool tread may be classified as a drum-type tread, a disc-type tread, or a horizontal-type tread. Multiple cutting tools can be mounted on the tread at the same time, allowing the machine to automatically select and change the tools required for each machining operation. This picture shows a typical CNC lathe machining operation. If you visit this channel, you will find many useful videos about CNC lathe and turning operations. Next, let us look at the sinker electrical discharge machine. It is commonly called a sinker EDM or simply an EDM machine. Put simply, this machine can perform machining operations that conventional cutting machines cannot easily accomplish. It is suitable for machining complicated areas that are difficult to reach with ordinary cutting tools. It is also effective for machining extremely hard and difficult to cut materials, such as a cemented carbide, which may be very difficult or practically impossible to machine with conventional cutting tools. Now, let us assume that we have a workpiece shaped like this. The drawing marked with a 4 radi shows the workpiece as viewed from above. As you can see, all 4 corners are rounded. A shape like this can be machined using an end mill. But what if the corners have no radius at all and are perfectly sharp as shown in this drawing? Would it still be possible to machine them with an end mill? If you look at the corner cross-section of an end mill, you can see that it is circular. The end mill removes material while rotating. Therefore, if the corners are sharp instead of rounded, the red areas will remain uncut. This happens because the cross-section of the end mill is circular. Do you understand why this happens? This is exactly when we use a sinker EDM machine. Electrical discharge machining requires an electrode. Generally, when the workpiece and the electrode are connected to the positive and negative poles, electrons are emitted from the negative electrode and move toward the positive electrode. As the electrons travel through the gap, they collide with other particles and cause ionization. This increases the number of free electrons. The closer they move toward the positive electrode, the more rapidly their numbers increases. This phenomenon is called an electron emergence. The resulting breakdown of the insulating medium produces an electrical discharge, and a large amount of heat is generated during this process. In electrical discharge machining, the workpiece and an electrode made of an electrical conductive and relatively easy to machine material, such as copper, brass, or graphite, are placed in a dielectric fluid. An impulse voltage of approximately 60 to 300 volts is applied between the electrode and the workpiece. When the gap between them is reduced to approximately 5 to 50 micrometers, dielectric breakdown occurs at a point between the microscopic surface irregularities of the electrode and the workpieces. The dielectric fluid becomes ionized, producing a spark discharge. The heat and explosive pressure generated by the discharge melt or vaporize a tiny amount of material from the workpiece, creating a small crater. By repeating this process, the machine can perform operations such as hole making, engraving, and complex shape machining. This photograph shows the inside of a sinker EDM machine and electrodes used for electrical discharge machining. If you visit this channel, you will find useful videos explain sinker electrical discharge machining. Finally, I would like to talk about wire electrical discharge machine, commonly called a wire EDM machine. I am both a motor engineer and a die and mold engineer. Motor cores are generally manufactured using press dies. One of the essential machines used to manufacture these press dies is the wire EDM machine. Some time ago, I worked as the head of the R&D center at MBM Tech, a company located in Jangnu, Gimhae, that manufactured BLDC motors for defense applications. Right next to the company was MTO, a specialist wire EDM company. If you would like to contact MTO, please email me at heung605@gmail.com and I will provide you with their contact information. This photograph shows the inside of the wire EDM machine. The picture in the upper right corner shows a motor core that has been This photograph shows the inside of wire EDM machine. The picture of the upper right corner shows a motor core that has been machined using wire EDM. If you visit this channel, you will be able to watch useful videos about wire electrical discharge machining. Everyone, do not become satisfied with your current success, knowledge, or experience. Always remain hungry for greater value, deeper knowledge, and continuous learning. This has been Robert Choi, a professional engineer in die and mold. Thank you very much for watching.